Hi everyone, welcome to another episode. Today, the question that we are gonna discuss was asked by Apple. Let's look at the question before jumping on the approach. So, the problem states something like this. So, you are given a multiplication table n cross n, and each of the 2D array value at ith row and jth column is calculated as I plus 1 multiplied by j plus 1, and you are given two integers n and x. Now you need to write a function that returns number of times x appears in the n cross n multiplication table, right? So let's look at the example to understand how they are trying to solve it. So you're given a n6 and x as 12, so you should return 4. Why? Because if we see the multiplication table n cross n, um, 12 appears 4 times, so that's our answer. Now, initially looking at this problem, the approach that strikes our mind is brute force, right? Like we can create a n cross n matrix and just iterate over each of the row and column and check if the value at that cell is equal to x, then we increment our answer. But that will take n cross n complexity. Let's look at the other approach that is quick and involves a little bit of maths. So uh, let me open this part. So the approach is, I'll keep this next to the question. So the approach is, we know x is 12, right? And we know n is 6. That means the number of rows is 6, and the tables in the each of the cell, the maximum table is of n6, right? Like this first row is of table 1, you can see this is table 2, table 3, and so on. Now what we can do is, if I try to find the factors of this value 12, so let's say 1 cross 12 gives me 12, right? The other one would be 2 cross 6 gives me 12. Another one would be 3 cross 4 gives me 12, and that's it. Why? Because we know, so yeah, 12 has these many factors, uh, and we know that n is 6, right? So we actually can cross this off and we can just have this, because it comes in table of 2, it comes in table of 6, because n is 6, right? So we increment it by let's say 2, so count is 2, and we also have table 3 and 4, so we have 2. Now many of you will say that okay, it doesn't it comes in table 1 and 12 as well, but n is not 12, is obviously less than 12, so we don't have that well. But what about this one? But again, we know that it's not possible to reach 12 because n is 6, right? So the solution to this problem is, we basically try to find all the factor pairs, and if both of the pairs are less than n, that means they exist, then we increment our answer by 2, right? Else we don't touch it, right? Now there are some corner cases here. What if x is a prime number? In that case we get two things, like let's say 5. So if 1 and 5 both are less than n, we basically have the answer as 2, else it will be 0, right? Now to efficiently solve this problem, I don't know if you guys can look it up, but the best way is to run a for loop from I1. You can run it from 2 because you are sure that there is, like, 1 is obviously a factor of this number x, right? So we start the loop from 2 till square root of x, and we can find all the values. So let's say for 12, x 12, what is the square root of 12 in integer values? It will be around 3. Now we run a for loop I equal to 2 to I less than equal to 3, I plus plus. Now if x is divisible by I, we know that it will be divisible by x divided by I as well. So there are two answers, x divided by I and I, right? So this will take 2 and this will take 6. Similarly for I3, I will be 3 and 12 divided by 3 will be 4. So that's how we'll make pairs. Now the best way to see how this problem approach works, let's look into the coding part of it. So this is our main method. Now I'm gonna create a dummy array for n equal to 6, right? So I'm gonna take n equal to 6 and I need to create a dummy matrix because that's our input, but we don't have that input here. Oh, actually, we don't need to create the vector. As we saw, we basically solve it based on x and I n. So we just take x and n as our input, and then we can start a for loop, and we keep a pair to store, and then we know a dot, so one pair will be equal to 1 comma x itself, right? And then we have I think sqrt in C++. There should be a method, right? I keep forgetting the syntax. Sqrtx, okay. Sqrt, we push underscore back make underscore pair. I do I comma x divided by, right? And simply after this is done, I just loop through. I keep my count equal to 0, and I just loop over the vector, and I check. I take the pair and then if temp dot first is less than equal to n and temp dot second is less than equal to n, we increment count by 2 and we print the count. So let's see for 6 and 12. Similarly for 6 and 5, I should get answer as 2. Nice. So I hope this question was clear. The overall time complexity will be O of square root of x, because that's our for loop's end value, and the space complexity will be around O of n. Hope you guys like the video. If so, please subscribe to my channel and give me a thumbs up. Thanks everyone.